This is Pete Lace, AVP of the product management team, and want to give you a preview here of the agenda that you see on your screen here. So for this month, we're gonna talk about two different push series refreshes: the ER8, the GT25, and we do have one NPI release, the KM32A. Joining us this afternoon, or if you're in the West Coast this morning, will be Zilly, who is going to talk about the ER8, and then Carrick for the GT25 and the KM32A. So Zilly, without further ado, sir, can you take us and lead us through the journey of our ER8, please?
Yeah, thanks for the introduction, Pete. So my name is Zilly. I'm the high-speed field application engineer here in the San Jose office. And today I'll be going over the ER8. So the ER8 is a SMT connector, a board-to-board high-speed connector with 0.8 millimeter pitch. And the high-speed transmission that it's targeting is for PCIe Gen 4, which is rated up to 16 gigabits per second. And one of the great things about this connector is that there's a lot of variety of pin counts, going from 10 to 140 pins, as well as very different stacking types as well. So there's your traditional mezzanine or parallel type. There's also a right angle and a coplanar type for this ER8. So if your customer needs some sort of different board-to-board configurations with high-speed transmission, this is a good connector for it. Another benefit is, compared to some of the older high-speed connectors, ER8 has really good mating interfaces and a good retention force, so you're less likely to run into some mechanical or assembly issues. The ER8 is actually a second source connector from Samtec's ER8, and what this means is we actually get a lot of inquiries about this connector, saying, "Oh, do you also make this connector?" And in our catalog page for the ER8, you're actually able to look up the specific Samtec ER8 connector part number to find a equivalent Hirose part number. So it's very easy if customers say, "Oh, we want this, but want Hirose to make it because Samtec can't support them for some reason." You can just quickly search that PDF sheet for the Samtec part number and find our ER8 part number equivalent. Another benefit too is our ER8, like all our high-speed connectors, is manufactured in Malaysia, which for some customers is very important because they don't want things to be made in China, or they want things to be made outside of China. So that's another benefit of this connector as well. So some design wins and target applications for the ER8 is listed here. So it's including but not exclusive to these applications, such as industrial devices, servers, server motors, server amplifiers, and PPC and MFP devices, so like printers. One big thing about the ER8 is because it has such good performance, we actually see this used in a lot of different applications. So I've seen it be used in things like high quality like cameras being used because it's just such a good board-to-board high-speed connector. So we're talking about high speed. A big question that always comes up is, okay, show us the data that it can run or support up to this speed. So this is this SI, or signal integrity performance, of this connector, showing that the insertion loss on the left, if the connector performance is above that red line, which is the PCIe specification, then it can support that. So you can see it is above that line, so it is able to support the high-speed transmission. However, a lot of times customers want more details. That's not just this. This is kind of a quick overview. So they want to see things such as like the return loss, the crosstalk, and also the signal integrity performance of the connector varies based on also the different configurations and heights. They vary slightly between all those configurations. So if someone wants that information, please reach out to a Hirose representative for more detailed SI information. So as I mentioned before, the ER8 has a lot of different configurations. So this is showing the ways you can get the different connection types. So if you're looking for a traditional parallel, like a board-to-board type, just have a straight receptacle and a straight header like this. And this is where we have the most pin count variations for, from 10 to 140 to 10 to 120. Then you also have a coplanar connection using a right angle receptacle and a right angle header. And this one we only have 120 pins for. And then you also have a right angle connection by using either a right angle header with a straight receptacle or a right angle receptacle with a straight header. So for parallel types, you have stacking heights from 7 to 12 millimeters. And as I mentioned before, you have a straight header and a straight receptacle to get this configuration. For the right angle connection type, you have two types you can use, which is a straight header and a right angle receptacle here, and a right angle header and a straight receptacle. And the differences between these two, other than just the pin count differences, is you can see here how much it sticks out from the board is different between these two. And based on the design, that might be something people need to consider, just because maybe you have some sort of clearance for something between the two boards. Then for the coplanar connection, you just connect a right angle header and a right angle receptacle. And as I mentioned before, there's only one pin variation for this, which is 120 pins. This is just a quick overview of the dimensions. From 10 to 120 positions, your width can vary from 10 millimeters to 54 millimeters, while for the coplanar type, your width is around 61 millimeters for 120 pins. Similarly, showing the dimensions for the two types of configurations for right angle. So it can either be a 61 millimeter width or 69 if you're using 140 pins. So the mechanical benefits I mentioned before, there's more on top of that too. So the ER8 has a plus or minus 1.6 millimeter self-alignment. That means during assembly, if it's difficult to see exactly how you're mating these due to the angle or some other reason, you're able to be off by this 1.6 millimeters in either the X or Y direction. And the self-alignment of the connector will make sure it slots in correctly into place without damage to the connector and making sure you have good electrical contact and SI performance. On the right is showing the differences between the insertion and extraction force to some of our older type of board-to-board connectors that are similar to the ER8, like the FX5. So here it's showing that you require less insertion force as well as less extraction force while still maintaining a stable connection. So the ER8 gets compared to a lot to our FX18 series because they're both 0.8 millimeter pitch SMT board-to-board connectors, and they can both support relatively high speeds as well. So this is just a quick slide showing the differences between the two connectors. So if your customers need something that's lower stacking height, that's where you would look at the ER8 that ranges from 7 to 12 millimeter stacking heights, as opposed to the FX18, which is goes from 15 to 40. Another benefit of the ER8 over the FX18 is that because the FX18 has 4 extra power pins on the side, it actually tends to be a larger connector than the ER8. So if space is a concern and your customers don't require the extra power pins, then it's better to move to the ER8 instead. And finally, one last thing I want to mention is, like all our high-speed connectors, the ER8 has a design guide that is shared and used along with the ER8. So this shows a lot more specific information than just what the catalog might show. it'll show you the material characteristics, gives you some design suggestions for how to actually design the PCB that the ER8 is connected to make sure you get the best performance possible, and some assembly instructions and recommendations as well. So this is a really helpful tool for people to say, hey, I want to use the ER8, but I don't know where to start or what to do with it. Well, we have the whole design guide that can show how to best use the ER8 without running into any issues further down the line. This is just quickly showing the recommended PCB layout. It varies from, of course, each specific part number, but just a quick overview of that. And here's the general specifications of as I mentioned, the materials of the two receptacle and header, as well as the electrical performance. If you're not looking at just the SI, looking at running power or current through it, you also see the performance characteristics down here. And this is just showing how you would get the part numbers with the different pin types. And that is it for my ER8 presentation. Were there any questions about this?
Zealy, thank you, sir. Yes, there's a few questions that popped up in the chat. First question, which I believe Carrick may have answered, but I'm not sure. I didn't really look closely yet. But Eric asked the question, what plating thickness do we currently support?
So you can see here, actually it doesn't show the specific thickness. Oh, the last slide. Yes, so yeah, so there is two types. There's the traditional 0.25 micron flash gold plating. So this one is for more like traditional usage, and for specifically telecom applications, they usually require a higher gold plating. So there's the 0.76 micron gold plating for that one.
Okay, all right, thank you. Second question is, are there any plans to develop the ER8 to clamp both sides of the PCB like the Samtec device?
I'm not too sure what they mean by clamp both sides here.
They gave a link in the
It's like
chat.
kind of a card edge style
Oh, okay.
for the mount.
Currently there are no plans to do that, but if there is such a need or request, please let us know and we'll look into it.
All right, let's see. Another question here is, where are the guidelines located? This person doesn't see it on the ER8 landing page.
Let me double check, but I believe it should be with the specific like part numbers page, but it's possible that it might have been moved around. So yeah, let me double check that for you.
Okay, all right. Let's see, I think I captured all the questions from the chat. Anyone else have a question they want to speak live or ask live?
Could you summarize the advantage of the Hirose ER8 offering over Samtec?
So it is a second source part, so dimensions wise, it's identical, but I think usually Samtec's business model is they built it on requests, and they may not do like factory assembly with it, so they might run into some issues with that part. While for us, it's all tooled up and it's a production line, so you're less likely to run into issues compared to a Samtec part.
When the customer asks me that, I tell them that we have more efficient manufacturing, so we can offer better price.
All right, anyone else before we turn it over to Carrick? Zealy, thank you again, sir. Carrick, it's all yours.
All right, come right up. You can see it.
Yes.
Yes.
Okay. So today I'm going to talk about some of Hirose's strongest wire-to-board connectors. So first up is this GT25. GT25 has become a cornerstone in the automotive industry over the past 8 years. Widely adopted by many leading automotive manufacturers, it's proven its reliability in various applications throughout modern vehicles. In the automotive world, this 0.64 millimeter contact thickness is a standard size, with the smallest corresponding pitch being 2.2 millimeters. As always, Hirose strives to understand the diverse needs of the market and offer a range of product variations. GT25 series is available in both right angle and vertical orientations, with pin counts ranging between 8 to 40 pins. As the pin count goes up, of course, the width of the connector increases, with the 8 position being about as wide as a thumb and the 40 position being about as wide as a credit card. Except for my thumbs, they're very large, you'll see later. I'm gonna try to turn my camera on because I always take not long enough on these presentations and show you a sample. Besides those normal right angle and vertical orientations, Hirose also offers this unique reverse Loctite, which I'm going to explain in a specialized slide about that. As durability and retention force are key for this product, a retainer is added to the crimp socket after the wires have been inserted. This greatly enhances the retention force of each wire so that even if you pull on a single wire by itself, it will remain firmly seated in the crimp housing. This prevents any accidental disconnections that could compromise vehicle safety or longevity. So at that 2.2 millimeters, GT25 has the smallest pitch in this terminal, this size terminal of connectors. However, it's also smaller in the height and depth dimensions. The slide shows the side-by-side comparison, which showing about 15 to 20% size reduction in each dimension when compared to other standard 0.64 terminal connectors. As we all know, smaller size means more flexibility when laying out the PCB. Traditionally, automotive manufacturers chose to use mostly through-hole mounted connectors to ensure they would never rip off the board. But recently, however, most companies prefer to save cost in the mounting process by using surface-mounted components. The pins on GT25 are surface-mounted, but 6 through-hole posts are also included for mechanical stability. These 6 through-hole pins are soldered using a pin and paste process, which means you can solder them using a normal surface mount oven rather than wave soldering. Of course, there's also no need to screw in a screw or anything, since the through-hole reflow pins provide more than enough stability on their own. As I mentioned before, we've seen GT25 used in many areas of the car, including speakers, cameras, LiDAR, headlights, infotainment, and many more. All right, so addressing that reverse Loctite I talked about before, a customer was designing a new car that had a front-facing camera mounted above the rear view mirror. There was no space to fit your finger between the connector and the roof, so the latch couldn't be depressed. With this reverse locking variation, the lock lever is on the bottom, so no extra space is needed above the connector. And in cases like this, the customer's issue is solved. So I know I did a simple application slide before, but this one shows a more detailed diagram of the main target applications for this connector. GT25 is perfect for mounting on the edge of the main multimedia control PCB and connecting to modules like the human interface displays, speakers, or telematics control unit. So let me test this out. I'm going to see if I can stop sharing, turn on my camera, and then we have to spotlight this for everyone. If anyone's able to spotlight this camera, that would help me out. Thank you. So now we can see I've got my calipers C size, my thumbs to C size, and then this is the 12 position for IID. This one actually is different from what I showed on the presentation because these are not through-hole pins. These are large surface mount pins, nothing on the bottom there. So that is actually a undercover variation we have available. Tried to stop talking so you could hear a click. It's pretty easy to operate. All right, back to our slides. Does anyone have any questions on GT25 before I move on to our new NPI?
Looks like nothing in the chat, Carrick.
That makes it easy. All right. Let me introduce you to Hirose's new KM32A series. This is not to be confused with the KM32 series without the A, which is actually a completely different part and uses a different crimp applicator. So first, here's a comparison with some of our other small automotive wire-to-board connectors. The GT25 from before, it has the bigger contact size and the 0.64 millimeter thickness, while the other three are reduced to 0.5 millimeter contact thickness. Despite this reduction in contact size, KM32A has very high current carrying capability and is rated at 5 amps per pin. The other main difference here is KM32A is single row, while the other three connectors have 2 rows of pins. This makes it smaller and better suited to applications which don't need as many pins, of course. So here's the official introduction slide showing the variations on the PCB. While we call these connectors automotive because they were developed for automotive applications, of course, they're also a good fit for any engineer who's worried about their connector breaking. Simply put, this connector is more durable and carries more current than wire-to-board connectors marketed towards less harsh environments. As Hirose works with next-generation electric vehicle manufacturers, we've been experiencing an increased need for weight reduction and PCB space efficiency. As a result, we're seeing more need for single-row connectors rather than dual-row. The connector lock structure was also designed and optimized for small size. The right-angle version is very low in height, allowing PCBs to be stacked closely together, while the vertical version allows maximum PCB space savings. All Hirose automotive wire-to-board connectors are polarized. This means if you try to insert it upside down, the plug won't be able to enter the header, and that will make it clear something is not right. Many of our competitors' connectors are not polarized, which can cause entire units to be scrapped due to damage caused by backwards insertion. So here's a comparison. The basic design of most latches is depicted on the left, and the protected lock design of KM32A is on the right. While the left side latch appears to perform the main function of keeping the connector mated, found that wires will get snagged, and in worst case scenario, it could cause the latch to permanently deform upwards, which of course compromises the strength of the connector. Probably one of the most important features of KM32A is that it has strong cable retention. Grounding surfaces and ribs allow each contact lance to hold itself in the crimp housing so strongly that it takes 60 newtons of force to pull the wire out. This means even if a single wire is pulled, it's very unlikely the connector will break. This is accomplished without adding a retainer, which means cable assembly requires one less step when compared to other connectors like GT25. So with the KM32A, mating confirmation comes in the form of an audible and tactile click. While this slide doesn't really help show the click, I encourage you to order some samples and try it out for yourself. It is a very strong tactile click, maybe similar to the GT25 I showed earlier. During long-term heavy vibration, many standard connectors will face plating damage and high contact resistance. KM32A is not like that. It has a vibration-resistant contact structure, which allows it to pass much harsher vibration testing than a standard wire-to-board connector. To be more specific about that vibration testing, KM32A has passed vibration at over 3 G's acceleration, 8 hours in each direction, all while simultaneously being subjected to harsh temperatures ranging from -40 to 125 degrees C. That test is summarized in the 4th row of this table and labeled complex environment. Now, turning our attention to the 1st row, we can see that KM32A is able to handle 11 amps per pin at 60 degrees C. At 125 degrees C, of course, it would be a different current rating, and we derate this connector as well. So with kind of like a derating of 50%, we arrive at the rated current of 5.5 amps per pin. Due to its competitive advantages in size, current rating, temperature, and vibration resistance, KM32A can be used in the harshest environments around the car, even if there are strict space constraints. For example, some places it has seen success are battery packs, various lights around the outside of the car, or sensing cameras. Many of the potential applications for this connector have only been recently invented and added to cars, meaning the market for connectors like this is likely to grow now and in the future. And as always, there will be many non-automotive customers looking for very robust connectors who would be a great fit for this product as well. So this is kind of the boring slide. I won't go over it all, but let me just point out that we plan to offer white and black colored housing options and 2 through 10 pin count variations. Okay, that's the presentation material, but before I ask for questions, let me make a quick notes. First, on the left side, Hirose manufactures connectors in multiple countries, and recently we've been getting an increase in inquiries about where each part comes from. So to answer this question, any of us can check the country of origin using Hirose's extranet portal under the pricing information tab. And last final reminder, our marketing team has been creating some great content and posting it on Hirose's YouTube and LinkedIn, which are linked on the right side. That's all. Any questions on KM32A, country of origin, ER8, or anything else?
Hey, Carrick, there's one question in the chat on the GT25, and the question is, who are the major competitors for the GT25?
So I don't actually know the answer off the top of my head, but we have done extensive research on this, and it actually can intermate with some competitors. So this is a product that was made to be similar to some other competitor connectors.
No worries on that, Carrick. Brenda, what we'll do is the PM special on this TAC Endo, he unfortunately had a conflict today for this monthly product focus training. So I will have Mr. Endo get in touch with you to let you know who the major competitors are. Thanks for your question, Brenda.